Hi, and welcome to Algebra Examples. I'm Dr. Finch. Today we're going to look at a limit and figure out what's going on here. In particular, we are looking at the algebraic part of the inner part of our limit here, the equation that we've got. This is going to give us a lot more information about what's going on, and working with the algebra is the hardest part of determining our limit, which is why we like to do problems like this. If you are unfamiliar with working with limits themselves, don't worry, just follow along with the algebra part. Most students who struggle with calculus, it is not the calculus that they struggle with, but the algebra. Okay, so starting with this, normally what we do when we work with a limit is we want to first take our number that we're going towards, x is moving towards infinity here, and we plug it in to see what happens. So when we plug infinity in for x, we get infinity plus infinity divided by infinity minus infinity. And we do not know what that is. So that means that we're going to have some work cut out for us. When you have a polynomial of some type divided by a polynomial, what we're going to do is we are going to look at the degree of the polynomial on top and the degree of the polynomial on bottom, and we're going to look at the highest exponent on both. In this case, it's both a 2, and that's the thing that we're going to pull out. We're going to kind of factor out an x squared on both the numerator and the denominator. Before we get into that, I'm going to start off by just changing our square root sign to a 1/2. A lot of times you want to do this when you're working with things like limits or integrals, because working with an exponent like 1/2 is a lot easier than working with the square root sign. Okay, so now we are going to pull out x squared from both the top and the bottom, and it might be a little bit difficult to see how that's going to go. So what we're going to do is I'm going to write it down one more time, and we're going to kind of pull through what we're doing here in order to get the x squared in all our terms so we can pull that out. So first thing we're going to do is we are going to multiply by a fancy 1 in our numerator. So this x to the 1/2, we're going to multiply by x squared divided by x squared. So we haven't really changed that term at all. We've just multiplied by a fancy 1. Second term, we're going to multiply by an unfancy 1, just a regular old 1. So now you can see in the numerator at least, what we're going to do is we're going to take this x squared in our first term and this x squared in our second term, and we're going to yank those out. And we're going to have some things left over. For our denominator, we already have a single x in our first term. So we only need one more x in the numerator, so we can multiply by x divided by x. And for our second term in the denominator, we're just going to change this into 1 times x squared. So let's see, over in our denominator, we have that x squared we're going to pull out. That's easy to see. In the first term, we have an x times an x that we're going to pull out. All right, let's factor that out then. Limit as x goes to infinity. We're going to factor out that x squared. We're going to have x to the 1/2 times 1 over x squared, plus our 1 survives in our numerator. And in our denominator, we are pulling out the x squared. We are left with a 2 divided by x minus 1. All right, so now our x squareds are going to cancel out. We're going to rewrite things just a little bit. I'm going to put a couple things on the side. Recall, first of all, that if we have x 1 over x to the a, this is x to the negative a. And x to the a, x to the b is x to the a plus b. If we put those two things together, x to the b over x to the a, we get x to the b minus a. So those are nice things to keep in mind when we're working with algebra problems. Those are good tools and we use them all the time. I'm going to use those exact tools right here in our first term on a numerator. We're going to pop that together so we have x to the 1/2 minus 2 all over 2 over x minus 1. And 1/2 minus 2, we can rewrite that as 1/2 minus 4 over 2, or x to the -3/2 over 2 over x minus 1. And I'm going to rewrite that one more time just so that we can kind of see what's going on. Remember, if there's a negative sign, you just throw that into the denominator. And if you recall, when we're looking at graphs, if you have a function that has a similar shape to y is equal to 1 over x, as x goes off to infinity here, our function goes to 0. So what's going to happen here is that first term on the numerator is going to go to 0. Our first term on the denominator is also going to go to 0 as x goes to infinity. And what we're left with is a positive 1 over a negative 1. So our solution is -1. There's a lot of really great algebra things in this sort of a problem. Keep those things in mind, and I encourage you, as you're working through things, have something at your side to remind yourself of all these nice little rules for algebra. That is going to be super useful in any calculus class that you have or algebra class. Thank you for listening.